Welcome back to the mountain bike build series. My son is becoming a man. This frame is coming close to being done. Look at all the work that we have and how far it's come. I think it's exciting. In this video, we're gonna design and then cut, then bend and miter the seat stays so they're ready for welding. Let's get into it. So if you're new to the channel, my name's Joe. I make frame building tools, Cobra frame building tooling, and then I'm also, documenting this build. And the idea is bringing people along through every step. If you're new to this, or if you just love seeing it happen, if you love seeing how different people work, that's the whole idea here. So we're gonna start off in BikeCAD. I'm using the auxiliary stay view that gives you this side profile, or this, I don't know, it's like you're looking straight on the face of it. And so we can see the seat stays here. And I was thinking earlier maybe I would do S-bend seat stays. That's where you put another bend right here, so it's like two opposing bends. That's popular these days, and there's nothing wrong with that, but I've always kind of preferred the look of the single bend rear end anyway. It's more of like a 80s, 90s mountain bike kind of look, and I think it looks good and simple, and that's just kind of what I feel like doing. So with my bender, you could pretty easily do S-bends, and I have a YouTube video about doing S-bends, but in this case I think I just want to do single bends. And so I have, in the wheel dialog box, the diameter and the width of the tire, the diameter of the wheel, width of the tire, and so that gives me the tire here modeled up, and then I just kind of do the bends around that. In this one I do, the number of curves, I do 1, I do the radius and how far I want it to kick off of the center line of the tube, where along the length of the tube I want that. You can do this as a ratio or in millimeters, doesn't really matter. And then I use the the dimensions dialog box to pull up certain dimensions, and these ones here show me the length from this point on the end of the tube to where the point of tangency is for the start of the bend, the degrees of bend, and then this here also shows me the miter angle against the dropouts. And so that's the information roughly that I need to do these. Whereas in the last video I drew it up with a Sharpie on my table. In this case I'm just using BikeCAD. So different ways to skin a cat, and that's what we're doing in this one. So we'll go chop the tube and start cutting and bending the tubes. So this is going to become our seat stays. This is 5/8 of an inch or 16 millimeter 4130 chromoly tubing. It's straight gauge tubing. So this isn't designed specifically for bikes. This is just chromoly tubing. I need to cut it roughly to length, and there's different ways to do that. So I could do a measurement in BikeCAD that would show me roughly the length I'm looking for. Another way to do that is to just walk over here to the frame fixture, and I can say, yep, I want it to be at least this long for a rough cut. That's one way to do it. So I can measure this, or you can just put the ruler on the frame fixture. Pretty obvious. And this is what I had worked out before, was like 480, 485, somewhere in there. So I'll just cut it a little bit long to be safe. Scribble this one out. So I'm going to cut 2 pieces to that length. So we're about ready to bend these heckin' tubes, and we need to know the degree of bend, and we need to know where along the tube do we do the bend. And so if we look at our beautiful Cobra Frames tube bender, we're going to slide the tubes in a certain amount, and the point of tangency is like right here, where the straight line of the tubes meet the arc of the bending die. And so you can figure out that point of tangency from BikeCAD, and that was my number that I had on screen earlier, and I'm just going to add a little bit because that was from like the dropout to the point of tangency, and the tubes are still rough cut, and so there's a little bit of extra length on either end. So I added just a little bit of length to that, and now I know how far to stick my tubes in. So I have it marked. The tubes go into this mark. I like using this square to square up the ends of the tubes so that they're really the same length projecting out of the tool. So by using this square, I can just really match them up. So the bends, because they're bending together and they're from the same material, I know they're going to get the same degree of bend almost exactly, like so close. It would be nearly impossible to measure the difference in the degree of bend between them, I think. But when you line up the ends, then they start the bend in the same place, and so it's really it's pretty repeatable at that point. So I'm tightening the clamp that holds the tubes. Then I drop in, this is called a follow bar. This cradles the back side of the tube, and if you followed the series, you've seen this a couple times. I'm just going to put a little bit of preload tension on this screw here, and that just keeps it all compressed. And now I'm going to drive the bend. So I want to have 17 degrees of bend, and if I just bring this to the 17 degree mark and then release the pressure, it'll spring back a bunch, right? So I want to go over 17 degrees, and I don't know exactly what to do, so I'm going to go to like 25 for starters. We'll see what that looks like. Let's do it. So there's all different ways to measure the degree of bend. One of the cool things about this bender is that because the tubes are straight here and then the bend is up here, you can use a level. And so, you know, I get this follow bar, so it's pushing against this bent section, and then I can read the angle off of this scale. So when I turn it on, you know, if this is vertical, which it is, then it'll tell me, you know, I subtract 90 minus 73, and that gives me 17, which is actually what I'm shooting for. And I figured out another way to measure the angle while it's in here, which is pretty nifty, and that's to use a little square like this. And so I get this follow bar, so, you know, like, it can't be down here. It needs to be parallel with the tubes. I use the square to sort of project this edge, and then a perpendicular line, which is this. And now I sort of look for when it looks like it's, you know, up here it's not parallel with my degree marks, and down here in the other direction it's not parallel, but at some point it'll become parallel. So it's a little bit sensitive, but you can read the angle like this. So it looks like, according to this method, I would say that I'm at 16 or 17 degrees. It maybe looks a little bit more like 16. And when I use this guy, you know, we had measured, that's more like 17, but you can see you can get pretty close measuring this way. So if you didn't have one of these around, it's just another option. So I'm going to say that we bent it where we needed to bend it. I'm feeling pretty good about that number, and I just take them out of the bender. Those look real nice. So at this wall thickness, 28 thousandths of an inch, this stuff is kind of fussy to bend. If you don't have nice tight-fitting dies, this stuff will ripple on the inside, and you know, sometimes worse. But when it's supported nice in dies like this that are hard and smooth with exactly the right geometry, it just cradles the tube, and it allows you to get a nice smooth bend. When I used to do this stuff on not ideal benders, it was very difficult to get smooth bends, and it was also difficult to get the bends placed exactly where I wanted, get the tubes to match each other. Everything about it was really difficult. Also, like, getting it bent to a particular degree of bend, very tricky, and this makes all those steps a lot easier. Being able to design on the computer and then walk over to your tool and quickly make the bends that you want to a known specification, and then move on, it's amazing. I used to not have any of this capability, and it gets me really excited to have this at my fingertips. So this is a good spot for bending. It's not a good spot for when I need to use the mill. I need to use the mill. Let's get this thing out of here. We're going to start mitering the seat stays. First, I want to do the dropout end where the seat stay meets the dropout, and that comes in at, I think, a 6-degree angle. And so remember, when I had them on the bender, I flushed up the ends of them with this square. That's helpful now. What I did is I used the Sharpie and then my calipers, and I scribed a line on either one of them. And that way I can cut up to that line when I'm mitering them, and it should make this distance from this line to the point of tangency of the bend the same on both of them, which is great. And in order to hold them to do that bend, or to do that cut, we're going to use the Miter Buddy. This is a tool I released a while ago. I haven't used it yet in this build series. There's some other videos on this channel outlining it. The Miter Buddy is exactly like the Miter Daddy, which we've been using on main tubes. It's very similar in a lot of ways, but this was designed specifically for this application. This holds the dropout end of seat stays, chain stays, and fork blades. And what this really excels at is, you know, right here we have a straight gauge tube. This is not as hard to hold on to, but a lot of times when you're using bike-specific tubing, it's got a taper as it approaches the dropout. And that is actually very difficult. How do you hold the tube on its taper? It's relatively thin wall stuff. If you just clamp it between parallel jaw faces, you're going to leave crease lines. If you try and hold it in a normal round tube block, on the larger, you know, like over its length here, it's tapering. So if you clamp it with traditional tube blocks, it's going to pinch on the large side and it's not going to be supported on the small side. And the beauty of this, which is also common to the Miter Daddy, is that this top clamp block can pivot. And so if the tube is coming to a point, this top one just pivots. It distributes the clamping load evenly across the whole thing. You get a nice solid hold. It's also 3 inches wide with parallel faces, and so it goes right in our milling machine vise real easy. So just a second ago off camera, I touched off on this fixed jaw, and then I moved back 1.5 inches. So 1.5 inches puts you right on the center line of the tube. So I just set it in the vise here, tighten up the handle. So now I need to set the angle of the cut. I need to have the tube sticking out of the holder just enough. And then the last thing that I need to do is, because there's this bend in here, I need to phase the tube. So I don't want the bend to be tipped back a little bit. And now I do the miter, and then you know, I want them to be in line with each other. And so the easiest way that I can think of to do that in this case is just kind of, it doesn't matter what the angle of this is yet. So I'm just going to swing it low. And now I have this block that's relatively square, and I can push the face of the block. I know it's dark back here, but I can push the face of the block against the tube. I can loosen up the clamp bolts here on the Miter Buddy, and I can twist the tube until it sits flat against this face here. And when it makes nice broad contact here, then I can tighten these up, and I know that the tube is in plane with this. On the milling machine, you would call this the XZ plane, but you know, with this sort of vertical plane. So I'm going to set the angle of cut, and my favorite way to do that is with the digital angle gauge. And in this particular setup, usually it doesn't do this so much, but it just keeps wanting to fall off for me today. I don't know if these magnets have gotten weaker or something, but there's a simple solution to that, which is that the tube is straight all the way until here, and you can just put this thing upside down. And what's great about that is that it actually reads, like, it knows that it's upside down, and it knows that you're probably right side up, and so it displays the digits so that you can still read them. And so this works fine in this case, and I can set the angle this way. So I'm gonna come up to my line here. It's kind of hard to see the line, so I got a flashlight, and I'm gonna turn the spindle on. I'm gonna slowly feed down. And I'm actually going to feed over until I approach my line. You don't really want to cut side to side, but I'm just skimming the top. I think it's okay. I like where it's sitting, and I'm going to make the cut now. One of the coolest things about this is that, you know, you can match the angle by, as long as you don't release the vise pressure on this, then the angle will stay the same. And so I'm just gonna, you know, loosen these, pull the tube out, put in the next tube, phase it again, and then I can make another cut. So I want to get about the right amount of stick out. You know, I don't want it way out here, and I don't want it choked up where I can't reach it. This is my squaring block. I see now, last time I did this was before I set the angle, so it's sitting up a little bit higher. I don't have as good a contact, but I don't want to change this angle. I'm actually going to lift the block up. These will be a good way to jack this block up a little bit without changing its squareness. I just rotate it until it makes nice broad contact.
So now we have the match pair. They're roughly the same length. The miters are exactly the same length from the point of tangency, exactly the same angle, and the bends are exactly the same. And so we can set them in here, but of course they're not ready to sit in the frame because there's interference. They're too long. We haven't mitered the other ends, so we can't really test the fit that well yet. They're mitered so that the center line of the tube intersects the center of this dummy axle, like the center of the dropouts. And so to sit at the angle that they need to this way in the frame, there's going to be interference. I'm going to have to grind part of this corner out here where it sits against the chainstay and the weld bead on the chainstay. That's not a big deal, but I haven't done that yet. So, you don't see the fit up yet until we do that other clearancing. So in order to do the seat stay miter where the seat stays intersect the seat tube, I'm gonna use my seat stay mitering fixture. I built this years ago. It was one of the first tools that I built for bike frame building stuff after I got this Bridgeport milling machine. And it was a fun learning project. I learned a lot from making this. And so it's not perfect, but it's gotten me through projects every time I've gone to use it. And so I've been lazy about building something better, and I never bought anything nicer. And so what it allows you to do is, here on the rear I have the sort of markings for different different widths of hubs, I guess. I use that as a reference along with a millimeter scale, and I can get these so that they're centered, and this here is like the center line of the fixture. So I'll center these little things, and that's just like I can butt up the ends of the tubes, and then the tubes sit against this edge. So it's really, when you have a cutout like this that's a half round shape, and you're using an end stop like this, you'd really like to have your end stop fit that half round shape at the right height. It becomes a lot more complicated because every different kind of dropout has a different sort of fit up. So I never bothered making all those, but ideally that's how you do it. This usually gets me pretty close, and it's usually been fine. So anyhow, this whole thing here slides, it's like on a sled or whatever, and so I can slide this part forward and backward when I loosen these clamps on the bottom. And because of this central rail, it's pretty square. It can't really wiggle more than, I don't know, 5 or so thousandths. I don't think that's quite 10,000ths of an inch. But anyway, it's not a whole lot. And so that allows you, if you had really short seat stays, you would slide it forward. If you had really long ones, you'd slide it back. And so I want to get to where it makes sense. It's got this block down here, and I'm going to hold that in my milling machine vise. I'm going to tip the whole thing up at an angle, and I'm going to drive my cutter in, and I'm going to cut both of these at the same time in the same setup. So this here is like a clamping block, and these little tube blocks hold the tubes from above. And so you can see the tubes are not fully cradled in tube blocks. It's really not the most robust setup, but it generally gets the job done if you're slow and careful. And so that's not really the best way to make a tool, but again, it's been a little bit hesitant to build a whole new fixture because usually I can get the job done with this. So here we have a threaded hole, and that's where this goes through, and I have a spring, which is kind of nice, helps support the whole thing. And then I've made a couple of these different custom like washers or bushings, and the idea is these are like a centering pilot. So this sets over the hole, and hopefully I have a tight fit against these threads. It's not a great design, but it kind of works. And so I thread this in, and now if everything was just right, you would be able to butt both of these tubes up against that little disc, and that would keep them centered on this end, and these, if they were adjusted right, would keep the tubes centered on the other end. And then you just have to get your cutter central to, like, the center line of the tool. And then these would all be symmetrical to each other. And so it's tricky for a number of reasons. One reason is that I don't have like 1,000 of these different washers in different sizes and profiles. That's one issue. Another issue, and I think this is common to seat stays generally, is that when they're finished, they're going to be mitered so that they fit pretty tight. and they're going to have a cut more or less out of the middle of them. But before they're mitered, they interfere with each other if they have a square cut on the end. So these have square cuts on the end, and if you were to lay them out in space at the same time, so they had the relationship to each other that you wanted when you were finished, they would interfere. So like in order to fit them both in at the same time, you need to cut some of that interference material away. Then you can load them in the tool, and then you can make your actual cut. Like, you know, make a rough cut to get that extra material out of the way. And you gotta be careful, because if you overshoot your rough cut, then you screwed the whole operation. So I've seen some people will actually do cuts one at a time, and then it doesn't matter so much about getting the rough cut where you want it. And so I need to think my way through how I want to go about this cut to make sure that I don't foobar it. You know, this is the only 5/8 tubing, I think, that I have around that'll do this task for me, so I don't want to cut it wrong. So on our little conundrum here, you know, how do we hold both tubes at once where they want to interfere with each other? Well, you can break it down. So right now, these are longer than they need to be total, and they have square cuts on them where they don't need to. So this line here represents roughly the angle that I could rough cut them at, so that it'd be long enough on the outside, short enough on the inside. And this line represents sort of what the finished miter is going to look like. Like, it's going to be a kind of a swoopy doopy cut, but that's sort of the angle of the cut roughly. And so the way that I derived that is I measured in BikeCAD from this edge to this edge, and I also measured from this edge to this edge, or you know, those points, point to point. So I dotted those on here, so I know that when the tube is finished being mitered, that is where the edge of the miter is going to sit along the center line of the tube, is right there and then right there. So that gives me, it's not actually cut straight, but that gives me an idea of where I could rough cut it to. So that helps. I just pulled those numbers straight out of BikeCAD. That's one of the really useful things about BikeCAD and then the auxiliary stay view. And if you did a 3D model in more powerful 3D modeling software, you could pull out even more numbers probably, but those are pretty helpful to get you off to the races. And so if I just, if I do a rough cut that's a little bit longer than those, that'll leave me a lot more clearance here to get these closer together. And then there's some other measurements that I could take to help me continue to set this up. So I used BikeCAD to spatially lay things out a little bit more, take a couple measurements, and I decided that I needed to make this disc to a particular thickness so that it would reach the center line of the tubes without interfering with my clamps that come in, these clamp blocks. So I got it to the right height, and then I needed it to be of a particular diameter so that it would space the stays apart. And now for fine tuning, I can slide this end a little bit, you know, longer or shorter. And as this is a fixed point here, this disc, then the tubes become relatively wider or narrower out here. So I have a little bit of fine tuning, and I knew I needed this to be about 50 millimeters in diameter. Someday I'll design a better seat stay fixture. So the outside, you know, miter to miter distance on this tube in a straight line, I think was 451. So I marked it from like the crotch of this cut, and I took the line, and this blue mark here is pretty much the length that I want it to be. And along the center line of the tube, it'll be the longest on this outside center line. So this is the 1.375 is the diameter of the tube that it's mitering against. And so basically, at that blue line, they are spaced apart. These are spaced apart at the width that I want. And so that looks good to me. I'm happy about that. And I can set it up on the machine. So this whole fixture is really not that robust. The tubes aren't held very well, and this isn't that much better, but I think it's gonna make a difference. I'm just gonna put this extra clamp bar across here, and what that'll do is it'll just support the tubes a little bit better, so they're less likely to wanna like pivot around by this one point that they're grabbed. But I mean, really, you wanna support tubes with like tube blocks or V blocks, and not just pinch them flat against flat. This isn't ideal, so I'm gonna have to take light cuts and have my fingers crossed. So the way this tool works is with these references, you can get the tubes symmetrical around the center line of the tool. and then you need to set it up, and you need to put it at the right angle. So I use my digital angle gauge to get it at the correct angle. And now I need to get on the center line of these tubes. And the way that I'm going to pick that up is I'm going to use my edge finder. But these edges are angled, right? The tubes are angled. And so what I'm going to do is I'm going to actually run the spindle in forward as I touch against this side, lift up, come over, and then I'm going to run the spindle in reverse as I run against this side. I don't know if that still does enough to cancel it out, but the way this works is the friction of the tip against the body of it is what lets you know when you're touching, and then it pushes off. Anyway, I think if you ran the spindle in the same direction in both ways, it might be a little asymmetrical in the way that it represents whether or not you're touching the tube. So I feed up. So I'm going to 0 on the y-axis. Now without moving the x-axis, I'm going to come across. Now I'm spinning in the other direction. So this way, like the little tip of the edge finder isn't like climbing up in one direction and then rolling down in the other direction. That might make a little bit of a difference, I'm not sure. So the way that I've done these cuts before is that it's not the way that I do it. It's not incredibly fussy on your total length. If you got it like a millimeter or so short, the seat stays would kind of sit lower on the seat tube, and if it was a little bit high, then they'd sit, or if it was a little bit long, they'd sit a little bit higher on the seat tube. And there's some margin in that latitude for it to sit higher or lower. As you get extreme, it would change the angle that they meet, and then your miter angle would be wrong. And so I want to make it fit the print, but it's not incredibly fussy. And so this blue line here is roughly where I want the outside diameter of this cutter to intersect against the tube. I think I'm about there. I'm going to use a square to check it, and then I'll make my first cut just a little bit long. This is about where I figured it needed to come to, so you can see we're a couple millimeters long, which is great. We didn't get a full cleanup right in here, so I'm gonna move the cutter over some and take another cut. I think I would like to take another cut, but now that I have the angle set and I have this backstop and I have this disc here, it's like kind of positively locating the tubes, and I can loosen this and I can get rid of this clamp. I can kind of dry fit it on the bike, more or less, and see where it's at, and then put it back in and take another cut. And it won't be that hard to set up the same way again, so I think I will take them out and check just to be careful. Crash landing! So, our stay, it won't fit because there's this clearancing I need to do here. But you can tell we're close. We're in the ballpark. You know, I can kind of set it off to the side here, and I can kind of push it up here. And so when I slide it in further and it gets to here, that'll lift this up some on here. I guess maybe before I put it back in the seat stay mitering fixture, I should, you know, get the Dremel or a hand file or something, and, you know, it'll take me a minute. I want to relieve material here so that they'll fit without a clearance issue, and I also don't want to remove too much because that'll make it really hard to weld without burning a big hole there. This has got a lot of mass to it, and this doesn't have much at all, so if there's a gap, it's going to be hard to weld. But yeah, I think that's the next step, is relieving the material here to make it fit. So if you look at the material we need to remove, a lot of it is just for this tube here, and it's a round shape, and it's coming in at a particular angle, and it's a lot like where we needed to fit up over here. We had to fit this secondary miter on this tube to the seat tube, and so you can kind of, I'm going to use something with a round profile to cut that shape. I'm going to try something a little crazy here. I've never done this before, but the other tube comes in at about this angle with a round shape. There's a round shape up here. This is way bigger in diameter. I'm just going to kind of rough it back a little bit, trying to use the top of this wheel. you can see when you get in there that I'm on the right track, but I need to be careful to get it right. You know, I don't want to be sloppy about this. Looks like I should move that cutting action more to this side of the tube, and you know, just keep at it slow and steady.
In Pennsylvania.
God damn, getting pretty close. So absolutely I'm on the right track. I just need to stay careful to not totally botch this. And one thing I want to measure is from the top edge down to the top of where it intersects here. I want to measure where I'm at already, because the question is, you know, after I finish this fit up, do I need to cut a little bit more off on the Bridgeport or not? So it looks like it's about 31 millimeters from the top is how it's modeled. It will sit a little bit lower after I have it fitting tight here. I think I'm just going to work on fitting these in, and I'll assume that it's probably close enough. I'll do a double check right at the end before it's, you know, ready for welding. What I'm really getting at here is that, you know, the cut we were doing on the Bridgeport as we brought the cutter down here on the end, if you were to cut that too short and you lay the tube in, it wouldn't sit here. It would end up fitting like lower on the tube, right? And so this is one way that I can measure whether or not the way that I cut this tube on the Bridgeport for length, whether or not that meets the design. It's just to see where does it sit, and then also to confirm that the angle was good, that there's no huge gap on the bottom or huge gap on the top, but that it's got a nice tight fit. And as of right now, it has a great fit, and I'm only going to dress the end of this so it should have basically the same angular relationship after I do that. So I'm pretty happy with the angle of cut, and I think the length of cut is acceptable because of where it's sitting on here height-wise. So it's just kind of fussy work going back and forth, you know, guess and check with the fit. And I don't feel like doing that on camera, but you understand the idea. You know, you just check to see if it fits, you look where it's interfering, and then you grind a little bit more off. After I do that, I'm going to do the Sharpie mark around the tube, Sharpie mark around the tube, so that I have a template for where to drill my vent holes. I'll drill a vent hole on this side and on this side, so those stays, the gases on the inside can pass freely into the seat tube. And the same thing, I'll drill a little hole here and here on the dropouts, so that gases can, and it's for the gases during welding and in the life of the bike. You know, condensation works its way into the bike frame whether you like it or not, and that it can drain out and that the air can exchange. You're not stuck with moist air inside of your frame is good when you're building with steel. And then it'll be, you know, just shine up the metal, clean things up, and it'll be ready for welding.